Welcome to the presentation where we will be learning about the scientific method as well as the metric system. The metric system is so amazing. I know everybody is excited to get started. In the metric system, there are a series of base units that are then going to be having prefix added on to them that will change their individual unit representation. The ones that we're going to be looking at primarily are the meter, which we use for distance, and this can be given the symbol with the lowercase letter m. We're also going to be looking at gram, which measures mass. This is going to be given the symbol of the lowercase g. And then the last that we'll be focusing on is the liter, which is going to be measuring our volume, measured in the symbol with the uppercase L. Okay, so now that we have seen that we have our base units that are the meter, the gram, and the liter for distance, mass, and volume, that when you add these prefix to these base units, such as the nano, micro, milli, centi, deci, deca, hecto, kilo, mega, we would then change the unit's value. So, if we add the deca to the meter, gram, or liter, having the decameter, decagram, decaliter, these would all equal then 10 of those units. So 1 decameter is equal to 10 meters. 1 decagram is equal to 10 grams. 1 decaliter equal to 10 liters. We can do the same with the kilo. If we add the kilo, we see the representative value is that of 1,000. So a kilometer equals 1,000 meters, a kilogram, 1,000 grams, and a kiloliter, 1,000 liters. So besides going larger in the prefix values, we can also go smaller. But note, everything is based on the scale of 10. So when we go to deci, a decimeter, decigram, or a deciliter are each a tenth of their original units. We go to the centi, which is a hundredth, and that would mean the centimeter, centigram, and the centiliter are a hundredth of the original value, and the same for milli. 1 millimeter, 1 milligram, or 1 milliliter are each a thousandth of the original value. Now, based that these units are all on the scale of tens, that when you are asked to do conversions within the metric system, it's really as simple as just moving the decimal position. So, if given the example of 874.45 km, which stands for kilometer, and you were asked to convert that into meters, which is the lowercase m, as we see represented here, that all you would need to do is look at where it's beginning with kilo standing for the 1,000, and you're converting it into smaller units, which here you would go back to the meter, which is the base unit as discussed previously. But because you're moving into smaller units, you will need more of those, so that 874.45 km would then move to the right the same number of values, which would be 3, and that becomes 874,450.0 meters. And the beautiful thing about the metric system, whereas before you were looking at measurements that were being converted as meters, the same works for volume when we start looking at 0.0049 cl, which is the centiliter, and centi refers to the hundredths again, and you're asked to convert that into mLs, which are the milliliter, which is the thousandths, which is equal to a cubic centimeter. But because you're going from centi to milli, which is a larger value to a smaller value, you still need to move that to the right the one position, and that 0.0049 cl would then be converted into 0.049 mLs in milliliters. Now for one more example, where we've done distance, we have done volume, we can also do mass, which here if we had 134,548.54 mgs, which is milligrams, if converted into kg, which represents, no, not Kevin Garnett, But kilograms, you would take the milli, which is here to the 10 to the negative third, representing the thousandth, and converting that to kilo, which is 10 to the third, which is the thousands. And because of this, this is a movement of 1, 2, 3, 4, 5, 6 units, and because you're going with a small unit into a larger unit, we would then move that to the left. So this, which here is the decimal position, we would move 1, 2, 3, 4, 5, 6. We place that decimal position down, and that then is our value in kilograms. Now there is the situation where you must convert sometimes one unit into a different unit altogether, whereas if you're converting pounds into kilograms. So if it were that you started with 190 pounds and you were asked to convert that into kilograms, well, first you would need an equivalent unit, which here we see that is in between the one unit and the other unit in value, where 1 gram equals 0.0022 pounds. Now, because we have this information, you will then next need to set up a cross multiplication that we see here, where this being the fixed ratio, the 1 gram is always going to be equal to the 0.0022 pounds, that then you just have to make sure that you set the pounds, as we see here on the denominator, being the same side, and then because we set that as equivalence, we just have to then solve for our unknown x. So now that we can do this, we just do the cross multiplication, where we take the 190 pounds times the 1 gram, as we see here, and we take that equal to the 0.0022 pounds times our x, and we set that equal to the other side. And once we now have our x, to isolate that, we divide each side by the 0.0022 pounds, and when that does, we cancel out our pounds and the 0.0022 on the right side of the equation, and then we cancel out the pounds to the left side, leaving us with 190 divided by 0.0022, which would then give us the unit that we have here as grams, but yet that here is 86,363.6 grams, and yet we still need to remember that we were asked to convert that into kg, which is the kilograms, but now because we are in the simple metric system, we just have to move that decimal position here to then 1, 2, 3 to the left, which then gives us our final answer, which is 86.364 kilograms. Now, if I could go back in time and just meet one historical figure, it may just be Sir Francis Bacon. He is the person who is the first to document the scientific method and started the ability for science's great discoveries. The steps of the scientific method always begin with observations of the natural world around us. And from these observations, scientists then ask questions. And these questions are geared to try to find answers about the natural world around us. So from those questions, the next step would also be to find research that what we already know about the natural world around us so that we can expand upon those observations and conclusions. But eventually, science, with all the research, all the observations, develop a working hypothesis, which these hypotheses are answers or predictions, more so, to our observations that explain the natural world around us, but yet there are some basic tenets of a hypothesis. That a hypothesis has to be testable, and it has to be also at the same time falsifiable and can be tested. So from these, we eventually work to make predictions that we can then put together into an experiment to test the hypothesis. Now, once we are able to test the hypothesis, through this experimentation, we gather more observations about that particular question. So from those observations that we collect, then data is going to be analyzed, and then eventually we can draw conclusions about those various experiments. So from this, it goes two ways. Either we have data that will support the hypothesis, and this has to be done over and over again to eventually draw more and more conclusions that are either supporting. However, the hypothesis can be tested, and if it is not that the data supports that, then of course we will reject that hypothesis, and then this is where the beauty of science comes. If the data is not supported, we don't have to stick ourselves into this one conclusion, but we can change the hypothesis. And then so from this point, we reevaluate the hypothesis and then continue the process until we can find conclusions that are supportive and have meaning to the world around us. Now, in science, data needs to be both accurate as well as precise. Accuracy means the degree in which your measurements reflect the actual value, which is kind of getting it right, but precision is also required, which means that you can get it right over and over and over again. So with the scientific method, through the observations, by asking questions that eventually allow scientists to state hypotheses that are testable and that include all of our observations, that eventually we can test this through experimentation, gathering more and more data over and over, that eventually lead us to draw these conclusions that will find the answers to the world around us. So when a hypothesis has withstood many tests and has yet been proven false, this in science is what we refer to as a theory.